All right. Good evening, everyone. Let me turn that down. Good evening, everyone. Please let me know that you can hear and then me. Can anybody hear me? All right. Good, good, good. All right. So, this is the study session for the final exam. We will go over some problems from the final exam study guide. I have it set up so that the majority, not the majority, but many of the questions are going to come from homework 13, which is the last homework. So that is, logarithms and things like that. And then the rest of the exam will be, just select the questions from the rest of the the rest of the course. So enough of me talking. Let's get started. Use properties to expand the following expression. Log of 4 times 6 plus x cubed over x to the fifth. Right. We are trying to expand. We're trying to expand this logarithm. All right. So there are the three properties that we're going to kind of use of that. Okay. Let's see. Make sure you can see that. Okay. The first, right over here. The first one is log base a of mn is equal to log m plus log of n. Make sure y'all can see that. The second one is log base a of m over n is equal to log of m minus log of n. And these both have bases of a on them. And the third one is log base a of m raised to the n power is equal to n times log base a of m. These are three properties we're going to use for that. Okay. So the first thing that we want to take this step by step. The first thing we're going to do is deal with this division sign because it's kind of first. So this is equal to log of 4. Is there a base on this? No. Log of 4 times 6 plus x cubed minus log of x to the fifth power. This is the quotient one. All right. Next, we are going to go ahead and separate because this is multiplication. 4 times that. So this is log of 4 plus log of 6 plus x cubed minus log of x to the fifth. The last one is we're going to deal with these exponents. So this is log of 4 plus 3 log of 6 plus x minus 5 log of x. And we have successfully completed this and expanded it completely. Nothing else we can do. All right. Also, I didn't say it, but per usual, if you have any particular questions, let me know. I left the final exam, I left the study guide kind of in order. So it's like the first 20 questions are logarithmic stuff, and then the blocks of 10 are the different units that we covered. So if you have a particular question on any of them, definitely feel free to let me know. Okay, this is a good one. Feels a little lighter in here than last time. But anyway, 27 is equal to 9 to the x minus 3. Right, the bases aren't the same, so we have to get the bases to be the same. Okay, obviously 27 and 9 are multiples of each other, but 27 is not a power of 9. But 27 is a power of 3, as is 9. So this is 3 cubed is equal to 3 squared to the x minus 3. 9 is 3 squared, 27 is 3 cubed. Okay, we multiply this 2 times all this out here. Because when we're doing power of a power, you multiply the exponents together. Right, so this becomes 3 cubed is equal to 3 to the 2x minus 6. Now, an equivalence property, a property that we use for this is a to the m is equal to a to the n, and that means that m is equal to n. So if 3 cubed is equal to 3 to the 2x minus 6, that means that 3 is equal to 2x minus 6. From here, algebra. 6 plus 6, 9 is equal to 2x divided by 2, divided by 2, and x is equal to 9 over 2. All right, I do glance up at my original problem, make sure that it doesn't cause any issues as far as things about zero and stuff like that. And it doesn't. So, okay, here's two questions. Okay, put them in the put them in the chat. It should let me know roughly. I'll have questions that'll be similar to. Oh, one, can we have our sheet of paper? Yes. Yes, I can choose that. Oh, yeah, yeah, so 20 is equal to LE of 10. Sorry about that. Maybe I should hit this up to where I move the paper and I move the thing, but we have a limit on this. Are there any complex we should focus on? Like I said, if you want to look at it as majority, like I need to look and see how many questions there are only. I made it, but I don't remember. Um, I would say the majority of it would be the majority of it's going to be on the last homework, and then it'll be equally distributed over the rest of the material. So you have like a math question. So this up at the top was taking logs apart. This is putting them together to solve it. So you do that. Josh, let me know if I didn't answer your question. So natural log of this minus natural log of that. So it becomes natural log of x plus 7 over 20 is equal to the natural log of 10. All right. The property that we talked about last time, we use it for exponents, but it also applies to logs, which is log of m. If log of m is equal to log of n, and that means that m is equal to n. Okay. So if natural log of this is equal to natural log of this, then that means that x plus 7 over 20 has to equal 10. After this, algebra. 20 times both sides, and end up with x plus 7 is equal to 200, and 7 minus 7, x is equal to 193. It is even more important here that we double check this. Okay. So, because especially with logarithms, it has to be, you can't do the natural log of something less than zero. You got to check it. Long story short. So, natural log of 193 plus 7 minus natural log of 20. That is the natural log of 200 minus natural log of 20, which combines with the natural log of 200, which is the natural log of 10. It works, and it does not lead to us taking the natural log of something less than zero. This is a good one. All right, number 4. So this is we're rewriting as a law as a logarithm as an differential equation. Log base 2 of 1 over 32 is equal to -5. All right, we are rewriting this um, as an exponential equation. So the base of this is the base of your exponent. Okay, so it's base raised to the answer. This is the answer. Base raised to the answer equals that. Okay, so this is 2 to the -5 is equal to 1 over 32, which we know is a true statement. So, yeah, there's a nice little acronym that I used to have about logs or base. I can't remember. I can't remember. It was a very good math joke. Okay. I don't think we need to do this, but why not? We're evaluating a couple of expressions. So log base 7 of 1 over 49 is equal to. And basically, when you're doing a problem like this, you're saying 7 to what power equals 1 over 49. We know 7 squared is 49. Okay. But it can't be 7 squared because it's 1 over 49. You also know that negative exponents flip it and make it like underneath 1. So this would be -2 because 7 and -2 is equal to 1 over 7 squared. Is 1 over 49. Similarly, log base 3 of 81. 3 to what power equals 81? That is 4. Because 9 squared, 3 to the 4th here. Yeah, because 3 to the 4 is equal to just 81. You could do that part in the calculator, but sometimes calculators these days will do logs with different bases, but they didn't do that. When I learned it, they didn't. The calculator change the base. I guess if I use it. Let's see. We did that. We can look at this problem. Okay. Whenever you see these, you definitely want to have your calculator handy. Okay, so um, 4 plus natural log of x minus 3 is equal to 3. All right, we want to solve this. We want to solve for x, which is kind of implied by the question. So we subtract 4 from both sides, and we get natural log of x minus 3 is equal to negative 1. Okay, from here we change it to exponential form. Exponential form. We know that natural log is log base e. This is the same thing as log base e of x minus 3. So we change this to exponential form. And this means that e to the negative 1 is equal to x minus 3 plus 3. So 3 plus e to the negative 1 is equal to x, which uh, e raised to negative 1, yuck, plus 3. So this is approximately equal to 3.3. And you can't see that. This screen so you can see that. All right, to check this answer, you definitely want to put 3.37 back in there. And you see that if I put 3.37 back here, I get a number that's larger than 0, which I need because I can't take the natural log of 0. Or really any log of 0. What can I get? Oh, here we go. On the study guide, do we have multiple attempts at it? So I can't redo questions. You should be able to redo questions. I will double check that for you to make sure that it's the right kind. Because for some reason the study guide did something weird on me. I want to make sure we're good. We did a problem like that. Same thing. Okay. This is a word problem. I'm not going to write it all the way out. But we'll do the same for all the word problems that you do like this. Okay, we have C of t is equal to 7 plus 13e to the negative 0.034t. Let me see if I can actually see this. Hold on. The one that says study guide correctly should read the questions. Yes. Okay, there we go. All right, the question says, Ellie places a bottle of water inside a cooler. As the water cools, its temperature, C of T in degrees Celsius, is given by the following function. Repeat the number of minutes since the bottle was placed in the cooler. And that's this equation here. Allie wants to drink the water when it reaches a temperature of 13 degrees Celsius. How many minutes should he leave it in the cooler? Round to the nearest tenth, and do not round any intermediate computations. That's a very, very important part. Not rounding the intermediate computations. As a matter of course, you shouldn't do. All right, so we want the temperature to be 13. So 13 is equal to 7 plus 13 e to the negative 0.034. Yes. All right. First, we isolate our e stuff. So, track 7, 6 is equal to 13 e to the negative 0.04t divided by 13, and 6 over 13 is equal to e to the negative 0.034t. Okay. From here, we're going to take the natural log of both sides. So we get natural log of 6 over 13 is equal to natural log of e to the 0.034t. With the natural log of e, they cancel each other out. I'm left with negative 0.034t. All right. So I'm going to divide both sides by negative 0.034. And right about here is when we start getting that calculator out. Because we need a calculator for this. So in the calculator, I'm going to do fraction. I'm going to do there's natural log of 6 over 13 over negative 0.034. And I end up with t about t being about equal to 22 point round to nearest tenth. So, David, I'll look into that after we finish this live stream. All right, this is graphing, which unfortunately I don't have a thing to do that. Expanding. Yeah, we'll do this one. So we have 3 log base c of 8w plus 1 plus 1/5 log base c of w plus 6. And we have been asked to write this expression as a single logarithm. Okay, I don't like that. All right, that's better. All right, we're going to use the same properties that we used earlier, and we're going to put them together. So the first thing that we want to do is we are going to move our coefficients to exponents. So this is log base c of 8w plus 1 q plus log base c of w plus 6 over 5. All right. From here, I'm going to combine them. Log of this plus log of this becomes multiplication. Log base c of 8w plus 1 q times w plus 6 to the 1/5. And that's our answer. That's our answer. There's no other thing that we can do with this. All right. More solving for x's. All right, so we're done with our logarithm part. Now we're going to go back to our trig part. Again, if you have any particular questions about this, please feel free to say them because the next I have in this study got 60 questions. The next 40 questions are things that we've already covered. Actually, I'm glad that you mentioned that. Let's go to the end and start because the end are questions that we did at the beginning of the year. Normally, I don't like to include these very much, but I got to include some. So let's do it. This will be a good review of things. If you have anything, let me know. All right. So I have 4/15 plus 3y. We have been asked to find the excluded values. Okay. As a review, excluded values are values that make the expression undefined. Values that make the expression undefined are the values that make the denominator equal 0. So to find the excluded values, say 15 plus 3y is equal to 0, and I solve. Whatever the solution of this is an excluded value. Minus 15, 3y is equal to negative 15 divided by 3. Y is equal to negative 15 divided by 3 is negative 5. Okay, well, this will be a blast from the past. Okay, for number 10, we have C is the set of V such that V is greater than or equal to 4. And I have D to V such that V is less than 8. We're asked to find C union D and C intersection D. Okay. So, easiest way to do this, in my opinion, if we do two number lines, this will be C, this will be D. So you label it kind of however you like. So let's say 4 and 8. So let's say this is 0 for both of them. 4, 8. All right. This may work. All right. Oh, y'all can see. You gotta tell me this. Okay. So for C, C is V is greater than or equal to 4. It's a closed circle in that way. It's all those. Okay. D is V such that V is less than 8. So that's an open circle. And let's break this. Okay. So the first question they ask is C union, the union of C and D, which is all together. If I were to merge all of these two lines together, I would end up with this would go into here. This overlaps it. So it would be the entire number. The answer is the union of C and D is negative infinity to infinity. Or some people complain because I do like circles. I like for it to be symmetric. So C union D is the union of these two lines. You overlap them, you get the whole number line. The intersection is where they overlap. overlap from here to here. All right. So the leftmost value that's on both of them is 4. I put a bracket because it includes 4. The rightmost value is 8, but it doesn't actually include this. Let's see. And those are our answers. Okay. Let's continue. So, okay. Graphing. So you can see this is talking. Okay, this will be interesting. All right, so f of x is equal to 7 over x, and g of x is equal to x minus 1. The question asks uh, f over g. Right, this is f over g, and this implies f over g of x. So f over g of x is f of x over g of x. In that case, that is f of x, which is 7 over x over x minus 1. Okay. Now, we have a complex fraction here. We have a fraction and a fraction. Right? So this is 7 over x divided by x minus 1, which is the same as if you keep change flip, which I don't like. But y'all remember that, which is 7 over x times x minus 1. All right. Since we have unions and things like that, let's go ahead and do all of them. So that's f over g of x, uh, f plus g of x is f of x plus g of x. This is formula functions. So this is 7 over x plus x minus 1. Not really anything you can do with that. I mean, we can play with it a little bit. It's going to be independent. 7 over x plus x squared over x plus x over x. So maybe I should do that just so you can see it. 7 over x plus x squared over x minus x over. And a property you can use, a property that we need to remember with this is that a over c, you can see that, plus b over c is equal to a plus b over c. So in this case, this would be 7 plus 7 plus 7 plus x squared minus x over x, which is x squared minus x plus 7 over x. The first one I like a little bit better, but the second one is manageable too. Right. Plus minus is the same thing. F times g of x is equal to f of x times g of x. All right, so that would be 7 over x times x plus 1, which would be 7 times x over x minus 7 over x. So this would be 7 minus 6 of x, or 7x minus 7 of x. All right, and we did the division. So the last one we'll do looking that looks like this is f composed with g of x, which is f of g of x. Composition is when you're putting a function into another function. Right? So this is the same as f of x minus 1. So everywhere there's an x in f, you put x minus 1. So this would be 7 over x minus 1. Okay. To be thorough, g of f of x is equal to g of f of x. Well, f of x is inside of g. Okay. So for our case, that would be g of 7 over x, which is 7 over x minus 1. Because that's what the x would normally be in g. So this is way more than the problem asks for, but you're liable to see something like this. I want to make sure that you have. Is there anything else that we need to be looking at? Plugging numbers in, you can do, say, we just did that. All right, let's see what we got here. All right, this talked about okay. This is interesting. I know I said it about every time, right? Okay. This is number, I got it right, 12. All right. So the question is, I have cotangent of 2 pi over 7. And they want the cofunction writing expression equal this. All right. So cofunctions are the cofunctions of cosine, sine. Actually, it's more like I want to write it accurately so you don't get mixed. Cosine of theta is sine of over 2 minus theta. Sine of theta is equal to cosine of over 2 minus theta. Tangent of theta is equal to cotangent of 2 minus theta. Tangent of over 2 minus theta. I know you're seeing the pattern here. Theta is equal to cosecant of pi over 2 minus theta. And cosecant of theta is equal to secant of pi over 2 minus theta. These are cofunctions. They kind of go together if you think about it. Sine, cosine, tangent, cotangent, secant, cosecant. Right? So if I have cotangent, the cofunction of this is tangent. So cotangent of 2 pi over 7, as you can see that, is equal to the tangent of, so cotangent of theta is equal to tangent of pi over 2 minus theta minus 2 pi over 7. All right, we're going to change this to both have the denominators of 14. So this is 7 pi over 14, and this is 4 pi over 14. So this is equal to tangent of 3 pi over 14. If I add 2 pi over 7 and 3 pi over 14, this becomes pi over 2, it's going to 4 pi over 14, 7 pi over 14, which is another cofunctions. What this means is that the cotangent of an angle in a triangle is equal to the tangent of 90 degrees minus that angle, because it's the same thing as 90 degrees. So basically, I have three angles in a triangle. In a right triangle, this is one angle. This, all right, that's a pretty question. I like that. Why not? All right, if theta is equal to pi over 3, it wants to find three things. All right. So the first thing it wants to find cosine of theta, which is cosine of pi over 3 over 2. All right, which is cosine of pi over 6, which is root 3 over 2. That's an easy one. Cosine of theta over 2, yeah. Pi over 3 divided by 2 is pi over 6. Right? That's an easy one. The cosine of negative theta, that's the same thing as cosine of negative pi over 3, which you may know this if you're familiar with it. If not, this is the same cosine of 5 pi over 3, which is the same thing as cosine of 5 pi over 3 is Josh, the syllabus addresses that. It's basically the percentage of the assignments that you pass, of the homework assignments that you pass. Cosine squared of theta is equal to cosine of pi over 3 squared, which is 1/2 cosine of pi over 3 is 1/2 squared, which is 1 over 4. So this problem was a little easier than I expected. A real one, then. It was not. Okay. So we have negative 220 degrees, and we want another reference. Okay. We know that the circle, half of the circle is 180 degrees. All right. So if, okay, let's do better than that. If I were to sketch the circle part, ain't no big deal, but you know, going to that. All right. If I were to sketch a unit circle here, a unit circle, you know that 180 degrees, positive or negative is halfway. So if we're going negative 220 degrees, we are rotating this way. And that'll be somewhere like here. Let's just say here, negative 220 degrees. That's 180, and it's also negative 180. The question is, the reference angle is how far is it to the nearest x-axis, not y-axis, x-axis. To go from 180 to 220 is how many degrees? You can't answer that because we're on YouTube. YouTube. But from here to here is 40 degrees. That's the reference angle. Reference angle is always positive. It's always acute. I don't think you need this, but go ahead. If I have 6 pi over 7, and I'm trying to change it to degrees, multiply by 180 degrees over pi. All right, this cancels. And I end up with 180 times negative 6 over 7. And I get negative 10, 80 over 7 degrees, which is approximately equal to negative 154.29 degrees. All right. Similarly, if I get if I have negative 0.79 radians, which is negative 0.79, like that, I'll multiply by radians to degree. I'm changing this from radians to degree too. I'm talking about the same thing. I'm 20 degrees over pi. And then you just subtract 0.79 times 80 over pi, and I get negative 45.26 degrees. All right, so radians to degree. This is what if you want to change from degrees to radians, I multiply by pi over 180 because I want the pi and I want to divide out the degrees. That's calculator work. Okay, this one right here is particularly fun. All right, so 16. Okay, so sine of alpha is equal to negative 15 over 17, and 180 degrees is less than alpha is less than 270 degrees. So we want to know the sine of alpha over 2 and the tangent of alpha over 2. Okay, there are half angle formulas that we're going to get to. The first thing we are going to do is we are going to sketch a picture. It is possible to do this without sketching a picture, but in my experience, it's always been easier to do it that way. This lets me know I'm in quadrant 3. This lets me know the right hand part lets me know I'm in quadrant 3. So the best theta, well, alpha. Alpha is 10. alpha, and sine is negative 15 over 7. The first thing we have to do is just use the Pythagorean theorem to find out what this x is. Unless you know Pythagorean triples, but I'll work it out just to be so. Negative 15 squared plus x squared is equal to 17 squared to 25 plus x is equal to 29 squared to 25. X squared is equal to 64. Means x is equal to root 64, which is 8. It's going to be negative 8. It's plus or minus 8. Quadrant 3. So if you think of this as a coordinate plane, this is negative. The hypotenuse is always positive, right? So we know that cosine alpha is equal to negative 8 over 17. So now we can do our formulas. So sine of alpha over 2, right, is equal to the square root of 1 minus cosine alpha over 2. That's equal to square root of 1 minus negative over 17 over 2. Just doing a little algebra here. 1 becomes 17 over 17. Because 17 over 17 minus a negative becomes plus 8 over 17 over 2. Is equal to the square root of 25 over 17, which again, more algebra, I end up with square root of 25 over 4, which is root 25 root 34, which is 5 over root 34, which is 5, oops, root 34, 34. This denominator is rationalized. By the way, we cannot have a radical in the. All right. So that's sine. So tangent of alpha over 2 is equal to, it's a couple of different formulas for this one. We'll do sine of alpha over 1 plus cosine of alpha. All right, more fraction work, but this is negative 15 over 17 over 1 plus negative 8 over 17. 1 is 17 over 17. Okay, so this becomes 15 over 17 over 17 minus 8 is 9. 9 over 17. Now, one of the properties of fractions is that if I have this is called a complex fraction. I have two fractions in a fraction. If the denominators are the same, you can cancel them or reduce them or whatever. And this ends up being negative 15 over 9 divided by 3, which is negative 5 over 3. Okay. This will be this I'm sure his calls. You need. Yeah, I can fit it. I don't know. Okay. I have secant squared x minus 1 times cosine squared x is equal to sine squared x. And we are trying to prove this. All right. You can start with the right side or the left side. You like to do side with more to work with, which is the left side. So let's do that. So if I have secant squared x, if I well, normally I would think to distribute this. That is a way to do it too. I don't know the easiest way that you understand doing this. We know that secant squared. Let's do it like this. Secant squared x minus 1 is tan squared x times cosine squared x. And we know that because this is a Pythagorean identity. Secant squared x minus 1 is tan squared x is equal to sine squared x over cosine squared x times cosine squared x. That is a quotient identity. And then this is like cosine over 1. I can cancel these. With sine squared x, and that is algebra. And I'm done. All right. Another way that we could have done this is distribute that cosine squared x, and I would get 1 minus cosine squared x. So there's more than one way to do this type of problem. This is a good one. Okay. We're running up on the hour mark. So if you have any questions, please go ahead and put them in the chat. Because another problem, then I'm going to go ahead and. All right. So they want to know the exact value of arc sine of cosine of 5 pi over 4. Okay. So to do this, we know that this arc sine is the same thing as sine inverse. Cosine of 5 pi over 4 is negative root 2 over 2. Right. What is the arc sine of negative root 2 over 2? Or in other words, the sine of what angle? If this is equal to theta, this is the same thing as sine of theta is equal to negative root 2 over 2. But remember that we're looking at from negative pi over 2 pi over 2. Because that is the range. That's arc sine has to be a theta. Right. Okay. Sine is negative. That means that it would be negative pi over 4. Let's write that be negative pi over 4. All right. Got a request in here. We did a question like number 18, David. That basically write the expression as a single logarithm. I did that. How many questions on the final? Is it timed? I believe there are 40 questions on the final, and it is timed. I think the time is 2 hours and 15 minutes. I can see if I can find that real quick. The final exam, I got 45 questions, and I got 2 hours minutes. I may see what I can do about making it 40. Just to, I mean, the normal final is about 20, 25 questions, and I give you an hour and 15. So if I double both of those, it's 2 hours and 34, 40 to 45. Any other questions? All right. So we've made an hour. If you have any questions after this, you can go ahead and be sure to send them to me via email. I'm going to try to be, because I know the final exam is coming up, I'm going to try to be as responsive as possible. I mean, I do have a day job, but let me know. All right. Have a good evening and good luck studying.